My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem solving questions. It has 174 data sufficiency questions. We have already solved every single one of these math problems. If you're interested in watching any one of the original solutions to these problems, you will find the original solutions from day number 1 through 250. Right now we are in the process of redoing the problems at a little bit of a faster pace, and we are on page number 270, or rather 280. Please turn to it, page number 280. The very first problem that you see there, number 57. In number 57, we are told that we have gift certificates. We are told that we have gift certificates of either $10, which we're going to represent with letter T, or $50 ones, which we're going to represent with letter F. F is going to represent the number of $50 gift certificates that we are going to deal with, and T is going to represent the number of $10 gift certificates that we're going to have. We are also told that we sold more than five worth $50 ones. We are told that we have sold more than 5 of the $50 gift certificates, which in our symbol, you're employing our symbol, T is for $10 gift certificate, F represents the number of $50 gift certificates that we have, and since we have just been told that it's more than 5, what this says is that F is more than 5. Let's continue. I don't want to go at too much of a leisurely pace. Sometimes I tend to do that. The question is simply this: how many were sold? How many total sold? How many total were sold, which in our symbol, which represent F plus T, equals how much? Let's see what they tell us, shall we? The first statement tells us that T is less than 10. It tells us that we sold fewer than 10 $10 gift certificates. We sold fewer than 10. It says yesterday the bookstore sold fewer than 10 gift certificates that cost $10 each, which is same as T is less than 10. Sold fewer than 10. Is that going to enable us to figure out how many total were sold? The answer is no. Simply knowing that we sold fewer than 10 $10 gift certificates, simply knowing that we sold fewer than 10 cheaper gift certificates is not going to enable us how many total we sold. There's not much in there. It is not a worthless information. It might come in handy later on. We do not know yet, but it's not enough. It's not sufficient. A, D, B, C, E. A, D, B, C, E. We just established this first statement by itself is not sufficient. Answer cannot be A or D. Let's look at second statement. Let's see what the second statement tells us. Second statement tells us that the total cost was $460. The cost of the total gift certificate that we sold was $460. Now what does it mean in terms of our equation? T represents the number of $10 gift certificates we have. So 10 times T represents the amount of money that we got by selling the $10 gift certificates, and 50 times F will represent the amount of money that we got from selling $50 gift certificates. This amount plus that amount we are told is 460. The entire equation is a multiple of 10, so let's divide it by 10 to make it simpler. What this tells us is that T plus 5F equals 46. Now, is that going to tell us what we need to know, which is how many total were sold? We're looking for the sum. Can we figure out the sum of F and T from this equation? The answer again is no, it's not enough. The second statement does not do the job. There is no way we can figure out the sum of T and F from this equation here. Answer cannot be B. Let's put them together, shall we? Let's put them together and see what happens. Let's do it on the top. When we put the two statements together, 1 and 2 together, then this is what we know. This is what you know. I need the room. I'm going to erase all of this thing. Keep this equation in mind. This is what we know. Here is the number of $50 ones that we sold, and here is the number of $10 that we sold. We know that we sold more than 5 $50 ones. And how do we know that? How do we know that? Because we are told that. We are told that in this question itself that we sold more than 5 $50 gift certificates. F is more than 5. The first statement tells us that T is less than 10. This is from the first statement. This is from the problem. Let's see what we can do. Since F is more than 5, we're going to start playing with it. That's all it is. Just start playing with it. 6 since it's more than 5, let's pretend F is 6. 6 times 50, because it's a $50 gift certificate, is 300. If this is 300, and since the total was 460, 460 minus 300, 460 minus 300 is 160, which means if it's 160, then we need 16 times $10 ones. But we are told that T has to be less than 10. T has to be less than 10. That's not going to work. We could not have possibly sold 16 $10 ones. We could not have possibly sold 16 $10 gift certificates because we are told that we sold fewer than 10. Let's try a second scenario. How about 7? 7, perhaps we sold 7 $50 gift certificates. 7 times 50 is 350. Whatever this amount was, it's going to be 50 less than that, so now it's going to be 110. Now it's going to be 110, which means 11 times 10 would have to be the amount. Again, that is not possible. We sold less than 10 $10 gift certificate. That is not possible. Perhaps we sold $400 worth of $50 gift certificate, which means we sold 8 of them. In which case, we subtract 50 from here, we get 6. Oh, there you go, 6 times 10. Now that is possible. That is possible. And this is possible. Sure, why not? But the question is that the end of the story? We can't just stop here. This is not the end of the story. If you stopped here, you might end up saying, well, we just figured out how many we sold. We have to ask ourselves, are there any other possible scenarios? So let's go one more step, and if it turns out that the next step for some reason does not work out, and this is the only scenario that works, then the answer in that case would be C. Putting the two statements together enable us to answer the question. The question was how many were sold? Well, 8 of these and 6 of these, assuming that there are no other possible scenarios. Let's try one more scenario, shall we? Perhaps we sold 9 of these. Perhaps we sold 9 of these, in which case this would be 450, and this would be minus 50 one more time, and this would be 10, which is 1 times 10. Oh my God, that also works. That scenario should also work. Why not? It is possible that we may have sold only one $10 gift certificate, only one $10 gift certificate. 10 is less than 10, T is less than 10, only one, and 9 $50 gift certificate, which is more than 5, and that also works. So the question is, which one is it? Obviously we can't go anymore. We cannot go anymore because if we go to 10, 10 times 50 is 500, and the total amount that we sold was 460, so we have to stop here. But the point here is, unfortunately we found 2 scenarios, scenario A and scenario B. The question is, which one is it? To which our answer would be, we do not know. The total number of gift certificates that the store has sold could very well be 8 plus 6, 8 plus 6, or 9 plus 1. The total number of gift certificates that the store has sold could very well be 14 or 10. We cannot tell, we cannot give a definite answer. The question was how many total number of gift certificates were sold, to which our answer is, we really don't know. They may have sold 10, they may have sold 14, we do not know. Answer is E. Answer is E. A, D, B, C, E. A, D, B, C, E. A, D, B, C, E. When we looked at the first statement, we found out that the first statement by itself was no good. First statement by itself was not sufficient. Based on that, we crossed out A and D. When we looked at the second statement by itself was also not sufficient. We crossed out B. The contest was between C and E. We just found out that putting the two together also does not get us anywhere. The answer is E. The answer to this problem, alas, is E, after all that work. But the point that you need to understand here is that, I'm about to break into a sermon, the point that we need to understand here is that in the real exam, you have to be able to do this thinking, logical, consistently logical thinking, in a pressured environment, in a pressured atmosphere, calmly, collectedly, and quickly, efficiently. Do you understand? We cannot take this kind of luxury that we do here. You have to be able to think all of this steps logically in a very fast, very rapid succession of thoughts. That's where we winnow out the boys from the men, or the girls from the women, if you like it, if you want to be not gender biased. Do you understand? The answer is E. If you do not know this expression, winnow out, learn it. This is where we winnow out the winners and the losers. Winnow out. Did we ever learn this expression? I know we are taking too much time, but I can't help it. Otherwise, I'm not going to. What the hell? Why is it that we have never learned these words before? I must make a note of these things, winnow out and pedantic, so that we can cover them. Winnow out. And the other one was pedantic. I'm going to write them down right now because otherwise I'm going to forget it. Winnow out means to separate the desired from the undesired. It has a literal meaning of separating the chaff from the wheat. Metaphorically, simply means to separate the desired from the undesired. Anyway, enough of the talk. Let's go on then. Otherwise, we will never get there. Number 58. We have quite a lot of work to do. We are only on number 1. Number 58. What is the 10th digit of a positive integer? Number 58. What is the 10th digit of a positive integer x? The first question tells us, my plan actually was to do this entire column in one video. I do not think it's going to happen because I have taken way too much time. I have taken inordinate amount of time explaining first question, and we are still only on number 2. What is the 10th digit of a positive integer? The first statement tells us, and that's all they're asking us, what they're looking for, a 10th digit of a positive integer. First statement tells us that x divided by 100 has a remainder of 30. Well, let's look at different scenarios where we'll make up a number for x, we'll divide it by 30, we'll divide it by 100 and see what happens. What happens to the number? What the number happens to be, such that we have a remainder of 30. X divided by 100, so maybe it's 130. 130 divided by 100 will give us a remainder of 30, wouldn't it? Right? Or perhaps it is 230. 230 divided by 100 will have a remainder of 30. Or perhaps it is 330. 330 divided by 100 will have a remainder of 30, and so on and so forth. It will go on forever. But the point is, are we able to answer the question that is being asked? The question is, what is the 10th digit? Well, it turns out that it doesn't matter what the value of the x is. The 10th digit in always turns out to be 3. The 10th digit is always 3. So the first statement by itself does the job quite nicely, quite beautifully. A, D, B, C, E. A, D, B, C, E. And it turns out that because of the fact that we just found out that the first statement does the job nicely, we know now the answer cannot be B, C, or E. It will have to be either A or D. If it turns out the second statement by itself is also sufficient, then the answer would be D. Let's look at second statement. In the second statement, they tell us that x divided by 110 has a remainder of 30. Has a remainder of 30. Let's see. In that case, x could be perhaps 140. 140 divided by 100, wouldn't it? But rather, 140 divided by 110 divided by 104 will have a remainder of 30, because 110 plus 30 is 140. Here, the unit, or rather the 10 digit in this case is 4. Or perhaps it is 140 plus 110, another 110, which is going to give us 250. And 250 divided by 110 will also give us a remainder of 30, because 110 plus 130, 110 is 220, 220 plus 30 is 250. Of course, by design, we simply added 110 to it, whatever the previous number was, so we simply added another 110 to it. We're just going one more round. This will also have a remainder of 30, but now the 10 digit happens to be 5. So we don't have to go any more in the real exam, you understand? In the real exam, we don't have to go any more. This is it, we are done. We cannot figure out what the 10 digit is. The end of the story, second statement by itself is not enough. I'm going to do one or two more rounds just to play around with, just to satisfy your curiosity. If you were to add another 110 to it, we get 360. And now the 10 digit is 6. We cannot tell what the 10 digit is. It depends on what the number is. If the number is 140, the 10 digit is 4. If the number happens to be 250, it's 5. If the number happens to be 360, the 10 digit happens to be 6. Second statement is no good. The answer is A. The answer is A. The answer is A. Let's take a look at number 59. Number 59. Just give me one. I'm going to actually go in the back of the camera. Just excuse me for 3 seconds. I'm still here. I'm very curious to see how long we have taken so far. Oh, we are 16 minutes to it. We'll do one more. Number 59. Number 59. I was about to stop here, but at the same time I was torn between my desire to stop here now and my desire to make sure that we do 59 and 57 in the same video, and you will see that, and you will see it in a second why. Number 59, I wanted to do it in the same video as 57 for a reason. Let's take a look at number 59. It says that number 59, how is it phrased? It says max is $125, consisting of, we have $125 in $5 bills and $20 bills. Again, the $5 bills we're going to represent with letter F, and $20 bills we're going to represent with letter T. And the question simply is, how much is F? Question is, how many $5 bills does he have, given the fact that we are told that he has $125 in total. Let's see what they tell us. The first statement tells us that he has fewer than 5. He has fewer than 5 $5 bills. Fewer than $5 bills. The reason I wanted to cover this question in the same video as number 57 is because it is very similar to 57 that we just did. If you recall, in 57 we had the exact same scenario. Instead of a $5 bill and a $10 bill, we had gift certificates. Well, you can think of gift certificates as dollar bills, or you can think of these dollar bills as the gift certificates. So here we have a $5 gift certificates and a $20 gift certificates. We are representing the number of $5 gift certificates with letter F. We are representing the number of $20 gift certificates with number T. We are told that we sold a total of $125 worth of gift certificates. We are told in the first statement the number of $5 gift certificates that we sold is less than 5. Let's see if that statement is enough to answer the question. The question is, how many exactly were sold of $5 gift certificates, or if you like, how many $5 bills we have. It's the exact same thing. It's just a matter of terminology, whether you call them gift certificates or whether you call them dollar bills. It doesn't really matter. They're very similar questions. Do you understand? They're identical questions. It's just they're playing with the words. Well, let's take a look at it. Here is our $5 gift certificates, $5 bills and $10 bills. And we are told that it's less than 5. Same exact thing as before. We're going to do the exact same routine as before. Since we are told that it's fewer than 5, we're going to start with 4. So if we have 4 of them, 4 times 5, because they are $5 gift certificate, $5 bills. So that's $20. If it's $20, and since the total is 125, this has got to be $105. Now the question is it possible to have $105 in $20 bills? Is it possible? Is 105 divisible by 20? The answer, of course, is not possible. Answer, of course, is no, it is not bloody well possible to have $105 in $20 bills. It's not possible. That scenario is not possible. Maybe we have only 3 $5 bills. Who knows? Maybe we only have 3, in which case we have $15 in $5 bills, and it will end up with $110 in $20 bills. Is it possible to have $120? Is it possible to have $110 in $20 bills? The answer is no. You cannot divide 110 by 20. That is not possible. Perhaps we have only two $5 bills, in which case it is $10. You see, you're beginning to see a pattern. Of course, in the real exam, you will pick up the speed, and you probably already saw the answer. You will see that this goes up by 5 each time, and it's not going to work out. And finally, we will have one $5 bills. We have only one $5 bills, leaving us with a total of $120 in the $20 bills, which is going to give us six $20 bills. This is going to give us 6 $20 bills. That's it. So the question was, what was the question? Question is, how many $5 we have? The answer is 1. The first statement by itself does the job nicely. A, D, B, C, E. Since we just found out that the first statement by itself is sufficient, we know now that the answer cannot be A or D. Do you understand? Just you try saying it rapidly like that and see what happens, okay? Let's look at second statement, shall we? The second statement tells us that $10 bills that we have has to be more than 5. $10 bills that we have is more than 5. And you already probably saw in a split second, as soon as I put this on the blackboard, you already probably saw it in a split second, that that's actually a very simple scenario. That's actually very simple. We need to erase all of this thing. You must always erase everything in your mind, in your memory, because the first statement has nothing to do with the second statement. Everything that we did in the first statement, it's all gone. It never existed. You understand? You must erase, you must delete your memory. It's all gone. All of this never existed. We look at this by itself. Well, we are told that we have more than, but at the same time, you must always remember that they never conflict each other. So even though technically we have erased our memory, but of course we have not, we remember what we found out. And if it turns out that we get conflicting information, then something has gone wrong. This tells us that we have more than 5 $20 bills. Let's pretend we have 6 of them. Let's pretend that we have 6 of them. So here's our $20 bills and here's our $5 bills. 6 times 20 will give us $120. We have a total of $125, which means we have one $5 bill. That's all. 1 and 6. The question was, how many $5 bills do we have? The answer is only 1. So second statement actually was very simple, very straightforward. And it turns out the second statement by itself is also sufficient. The answer is, what the hell did I just do here? Didn't we just find out that the first statement by itself was sufficient? I was too cocky into how fast I was saying, and I mucked it up. The first statement by itself was sufficient. First statement by itself was quite sufficient. That tells us that the answer cannot be B, C, or E. Answer would have to be either A or D. Since we just found out that the second statement by itself is also sufficient, the answer is D. The answer is D. That was it. Which is why it helps to write this down right away, because once in a while you can catch yourself like that. That was it. I'll see you tomorrow, okay? My plan was to do the entire column, but I'm not going to do that. That'll be too long of a video. I don't want to babble here for an hour. That will bore the pants off you, wouldn't it? Well, I'll see you tomorrow, okay? Bye now.